Welcome! Today we're going to learn about the first derivative test. So first let's talk about the test itself. First of all, we need a function that is continuous and differentiable on an open interval, except possibly at its critical number c. And then the following four scenarios are true. So in the first scenario, if you look at item 1, you can see our critical value c. And then if you look at our graph to the left of C, it is decreasing. When we move from left to right, we see that the graph is going down, it is decreasing. And what does that mean? Well, it means that the first derivative is less than 0 or negative. And so then we want to look to the right of our critical value, and you can see the graph is increasing, which means that our first derivative is greater than 0 or positive. So according to this test, if we look to the left, move from the left to the right of our critical value, and we switch from the first derivative going from negative to positive at that situation, then we have ourselves a relative minimum. So we're looking to the left, to the right of our critical value, what's happening with our first derivative, and if we go from negative to positive, we have ourselves a minimum, relative minimum. So let's look at item 2. This is the opposite scenario. Our graph is actually increasing to the left of C and decreasing to the right of C. So our first derivative is moving from positive to negative, and that gives us a relative maximum. And again, looking at the shape of the graph, you can see it's in the shape of kind of a hill, or which would be a maximum, whereas the other one was more like a valley or a minimum. Now, in items 3 and 4, the situation is such that to the left or right of our critical number, they're the same. In other words, we go from positive to positive for our first derivative, or in item 4, from negative to negative. And in both those situations, we conclude that we have neither a relative minimum or a relative maximum. So let's do an example. So we have our function in 1, and then in item 2, we're going to take its first derivative, set it equal to 0. In item 3, we factor, and in 4, we solve. Now, why are we doing this? Well, that's how we're going to calculate our critical values in this particular example. So when we do that, we get critical values, or x values, of 0 and 2. So what do we know? Well, at these critical values, we're going to see if we have a maximum or a minimum at either of these critical values. We're looking for extrema, so that's what we're looking for. So we have to test to determine if that's the case. So what are we going to do? We want to see what's going on with that first derivative, right? Because that's what our test says. We have to see what's happening with the first derivative. So first thing we want to do is establish intervals around the critical values. So in item 5, that row, if you look at column 9, our first interval we're going to establish is between negative infinity and 0. Well, that represents everything to the left of our critical value, 0. In column 10, we're going to look at an interval between 0 and 2. Well, that interval would represent anything to the right of our 0 critical value, but to the left of our critical value number 2. And then in column 11, that interval goes between 2 and infinity, and that's anything to the right of critical value 2. Okay, so now we move on to testing values. We have to figure out, first of all, what we're going to test. So if we look at row 6, or you look at item 6, that row, again, start with column 9. We chose negative 1. It could be anything within that interval, okay, from negative infinity to 0. In column 10, we chose 1. In column 11, we chose 3. So moving on to 7, again, going back to column 9, if we plug negative 1 into the first derivative of our function, we get a negative answer. In column 10, when we plug 1 into the first derivative, we get a positive answer. And in column 11, we choose 3 as our test value. We plug that into the first derivative, and we get a negative answer. So what can we conclude? In row 8, you can see, starting with column 9, that our function must be decreasing in that interval. Why? Because our first derivative was negative. In column 10, in the interval between 0 and 2, our function is increasing. Again, because our first derivative is positive. And then in column 11, we can determine in the interval from 2 to positive infinity that our function is decreasing. Okay, so let's see what all this, we have to come up with some a result here. So if you look at 12, okay, 12, item 12, that's really, where each column to the left and to the right of our critical value 0 are really telling us what's going on. In column 9, we determined that our function was decreasing, so that's to the left of 0. In column 10, we determined the function was increasing. Well, that's to the right of our critical value 0. Now, according to the first derivative test, if the first derivative is negative to the left and positive to the right of our critical value, that is a relative minimum at that value. So at 0, we have ourselves a relative minimum. And if you look at the shape of the graph, it's the shape of a valley, which kind of indicates minimum, okay? So you can get a sense that way. Now if we look at item 13, well, in column 10, in other words, to the left of our critical value 2, our function was increasing. Our first derivative was positive. To the right of critical value 2, in other words, in column 11, our function was decreasing and our first derivative was negative. So we went from positive to negative. And according to the first derivative test, that tells us we have our relative maximum at that critical value. In this case, it's 2. So we have a relative minimum at 0, and we have a relative maximum at 2. All right, so let's test our theory here, see if it actually works. So if you look at our function, and this is a graph of our function, we want to know what's going on at 0 and 2. And if you look at the x value of 0, this is item 1, you'll see it looks like we've got a relative minimum there, okay? And if you look at the x value of 2, and it's item 2, we have our graph is at a relative maximum at that value. So we have verified this by looking at the actual graph, and it works. Now, if you're not familiar with the terms critical value and some of the other terminology, extrema, I do have other videos that explain that in more detail because some different scenarios will create different situations. So I want to make sure you check those out if you're not familiar with them. But we are done. This is the first derivative test. Now go practice, practice, and practice some more.